Okay, so Unit 3, Lesson 5. This is the last lesson in Unit 3. And in this lesson, we are going to be writing and graphing equations of lines. So in this first example, we are going to write an equation of a line from a graph. And we are going to write this equation in slope-intercept form. And this is remembering from Algebra 1. Slope-intercept form is this y equals mx plus b, where m is the slope, b is the y-intercept. So in this equation, or in this graph, our y-intercept, it's kind of hard to read this, but this is the y-intercept of 1, 2, 3, 4. So our y-intercept is 4. So I'm just going to write b is 4. And then our slope, we just did a lesson on slope, but it's a little bit easier when you're given the graph because you could actually count the slope. Rise over run. You go down 1, 2, 3, 4, 5, 6. So my rise is -6. My run is 1, 2, 3, +3. So simplified, my slope is -2. So I've got my slope, I've got my y-intercept. I can write my equation. Y equals -2x plus 4. -2x plus 4. That is my equation in slope-intercept form. Okay. So moving to example 2, writing an equation of a parallel line. This is remembering what parallel slope means. So for this example, it says write an equation of the line passing through the point -1, +1, and parallel to the line with this equation. So when we talk about parallel lines, all we are concerned with is the slope. So this line that we're given, the only thing we're concerned with is the number 2. We are not concerned with the y-intercept of that line. All we care about is that the slope of our line needs to be parallel to the slope of this given line, which means that our slope should be 2. Now to write our equation, the line passes through this point. If you notice, this is an x, y point. So if I'm going to use my y equals mx plus b form, I'm going to substitute in 1 for y, 2 is my slope, and I am substituting -1 in for x. The reason I'm doing that is because I am substituting these values in to find out the value of b, which I don't know yet, of my new line. So I'm substituting -1 for x, +1 for y, and then 2 for m for my slope. So to solve this, I'm just going to bring this over here. This is 1 equals -2 plus b. I add 2 to both sides. 2's cancel. My b value, my y-intercept, is 3. So essentially you're substituting in known values to find that y-intercept. Just like the last equation. I know my slope, I know my y-intercept, I can write my slope-intercept equation. 2x plus 3. So when you're given a point, you are given an x value, you are given a y value. You substitute those values into this y equals mx plus b formula. And then you solve for the value you are looking for. Now in this next example, perpendicular. So we're writing the equation of a line passing through this point and perpendicular to the given line. So for this example, we need to know perpendicular means the opposite reciprocal from our last lesson. So if our given slope of this line is -2, the slope of our perpendicular line is going to be opposite, meaning it's going to be positive, and it's the reciprocal of 2. The reciprocal of 2 is 1/2. So perpendicular is the opposite reciprocal. And then we do exactly what we did before. I'm just going to still write out my y equals mx plus b. I know an x value, I know a y value, I know the m value. I have to find that b value. So I substitute 3 for y, 1/2 for m, 2 for x, and then I'm going to leave b as b because I don't know what b is yet. So again, just to show my work, 3 is going to equal 1/2 times 2, which is 1, plus b. And then to solve that, subtract 1 from both sides. B is 2. So that gives me all the information I need to write my equation. Y equals 1/2 x plus 2. That is my y equals mx plus b equation. So the thing that people usually get confused with in these types of problems is they think with this given line that this number 2 as the y-intercept, that this means anything. It doesn't. All it does is tells us the y-intercept of that line. The y-intercept of that line does not affect the new line that we draw. All we are focused on is this number right here, the slope, that -2. So next, it's time for some guided practice. I want you guys to pause the video, work through these, and then give me a few seconds and then check my answers, compare them with yours, and then determine if you need some extra help or some extra support. Remember, I am here to help. These notes are mainly for you to work through at your own pace and for me to individually help people. So pause the video, cross-check your answers with my answers when you're ready. Okay, so sorry for not giving you a heads up, but there is another guided practice on the back of this page. So if you got to that, great. If you didn't, I'll just explain it. If you want to pause the video now and do that number 3 for the guided practice, you can flip over your page and try that. But I'm going to explain my answers for 1 and 2 first. So in number 1, it's just simply finding the y-intercept on the graph. The y-intercept is where your graph or your line crosses the y-axis. That is this point. The y-intercept is -1. And then I counted my slope. Rise of 2, run of 1, 2, 3. So knowing the slope, knowing the y-intercept, I can write the slope-intercept form. So that's about as simple as I can make it for the finding the equation. Now in number 2, I understand that this kind of extended what we were talking about. So you're given 2 points. So if you're given 2 points, you can find the slope. y2 minus y1 over x2 minus x1. That was the last lesson. So I get my slope is, I should have wrote that better, my slope is -1. Okay, my slope is -1. And then from our examples before, you can choose either point to plug in to y equals mx plus b. I just picked the point 1, 2 because the numbers are smaller. That's essentially it. But you will get the same equation no matter which point you use. So I substituted in 1 for x, 2 for y, and then -1 for my slope. And I solved for my y-intercept. I got the equation y equals x plus 3. So if you have any questions on how I solved this, or if you solved it a different way, or just were totally lost, let me know and I will work through it with you personally. I forgot already. Example 2. Okay, it's very similar. And then to show you number 3, it's very similar to example 2. The slope that is parallel is a slope of 3. So I already know my slope is 3, and I know it passes through the point 1, 5. So I substituted 1 for x, 5 for y, and 3 for m in this y equals mx plus b formula. I solved for b, I got 2. So my equation is y equals 3x plus 2. So again, if you have any questions on those, I will personally help you work through them and understand them better. Now next, writing an equation of a line from a graph. Now this is a situation, a real life situation. The graph models the cost of joining a gym. Write an equation, explain the meaning of the slope and the y-intercept of the line. So from this, I can find the slope. Now finding the slope is going to be a little bit tougher because you can't necessarily count. So we're going to have to use y2 minus y1. So I would do 363 minus 231 as my rise, those are y values, over my run of 5 minus 2. So this becomes 132 over 3, which then becomes 44. So my slope, m, is 44. From that, I can use one of the points to find my y-intercept. I know my y-intercept is going to be less than 200, so that's going to help me understand if I solved it right. So let's use the point 231. Let's use that as our point. So the way I'd substitute this in, 231y equals mx, 44m times x, which in this case is 2, plus b. So 231 equals 88 plus b. So I would solve that by subtracting 231 minus 88. So my y-intercept is 143. Okay, so to give me some room, I'm going to write my equation up top in green here just to show you. So my equation is y equals 44x plus 143. And I didn't fully answer the question because I want to know the meaning of the slope and the y-intercept for this gym membership. Okay, so the 143, that is our y-intercept right here. So that is the cost for 0 months, right? So the 143 I would think would be just the cost to join the gym. So I would say 143, you could say the cost to initially join. Okay, join. All right, that's our y-intercept. Our slope, 44. I would think that our cost is going up as the months go by, so 44 represents the monthly cost. Or monthly fee, however you say it. But the monthly, I'll say monthly fee that they charge you for being in the gym. So the 143 could be an upfront cost that you pay initially. So maybe the cost to rent your locker or just maybe some equipment they give you at the beginning. But that's your initial cost. So you pay that, and then you pay an additional $44 a month on top of that. So those are good things to know how to describe. In example 5, you're going to graph a line that's in standard form. So that's a line that's not quite in our y equals mx plus b form yet. So the way I would graph this is I would force this to be in y equals mx plus b form. Meaning I would solve for y. And the way I would solve for y is I would get rid of 3x and I would get rid of 4. So the way I get rid of 3x, the way I move it to the other side, I would subtract 3x from both sides to get it to cancel. So this is 4y equals negative 3x plus 12. And then to solve for y, I am going to divide both sides by 4. And that means divide everything by 4. So my equation is negative 3/4 x plus 3. Meaning I have a y-intercept of 3 right here and a slope of negative 3/4. So I would go down 1, 2, 3, right, 1, 2, 3, 4. So I graph my y-intercept, I graph my slope off of that, and then I can draw a line. I can draw a line through these 2 points. Don't mind that little smudge I made there. So that is my line. So if it's not in y equals mx plus b form, you can solve for y. It doesn't take much to solve for y. Okay, and then finally, example 6. I know this is a long lesson, but this is a lot of information. So this example, it says a national park has 2 options. You pay $50 for a yearly pass, meaning $50 you can come and go as you please. It costs you that flat $50, or a $4 entrance fee for each time you enter. So to model this cost, I would say X is the number of visits. You can kind of see that down here. And Y is the fee. Okay? So For the first example, or the first option, your $50 yearly pass, your entrance fee is a flat fee. You don't pay anything extra off of that. So the equation I would write is my fee, Y, is just always 50. It doesn't go up, it doesn't go down. I pay that one time. Now, for the $4 each time you enter, my fee is going to depend on how many times I enter, or how many times I visit. So if I visit once, it's $4. Twice, it's $8. 3 times, it's $12. So my equation would be Y equals 4 times X. Because if I don't go, I don't pay. I just have to pay every time I go. So we're going to graph each of these to help us find out when the annual pass becomes cheaper, because eventually it becomes cheaper. So the way I would graph this, I have a point, my y-intercept is 50, and my slope is essentially 0, meaning this is just a horizontal line. And this is always going to be 50. Okay, my cost will be 50 flat, no matter what. For my my daily fee, I pay $0 for 0 entrances. And now this is a little hard to do because you think like up 4 over 1. I just want to make sure we understand. If I visit 5 times, how much would I pay? If I visit 5 times, I would pay $20. 5 times 4 is 20. If I visit 10 times, I pay $40. 4 times 10 is 40. Sorry, 4 times 10 is 40. Sorry about that. And then 15 times, 4 times 15 is 60. So my equation is going to go right about there, and we see where they cross. That is the interesting point. So this is the interesting point right here, where they intersect. And it's really hard to tell because it looks like it's halfway in between. So one way you could figure out mathematically when they're the same is you could just do the equations and set them equal to each other, right? You want to figure out how many visits it takes you to get to $50. So if I divide both sides by 4, x is going to be, it's a little over 12. So it's 12 and a half. Now you can't have a half a visit, okay? How many visits will make the annual pass cheaper? 13 visits, basically, because you can only do whole visits, right? So on that 13th visit, the annual pass is actually cheaper. So basically, if you go more than once a month, the annual pass becomes cheaper. So that's a good way to compare two things and then see when one overtakes the other. So I know these notes were long. Hopefully you guys are kind of taking pause breaks in between, taking some brain breaks, but now I think you're probably ready for the next activity or practice. And just let me know if there's anything I missed here that you need help with.